The molecular basis of immune recognition of gluten in celiac disease. Gluten is the collective term used for a family of related cereal storage proteins in grains of wheat, barley, and rye. A distinctive feature of gluten proteins is that nearly half of the amino acid content is accounted for by just two amino acids, glutamine and proline. Glutamine is represented by the letter Q. When the epithelium and underlying tissue is inflamed or injured, one of the responses to promote recovery is to increase the levels of transglutaminase, or TTG. TTG is an enzyme that specifically targets and modifies glutamine residues in proteins. Short strings of amino acids, known as peptides, remain as indigestible fragments of gluten that are rich in proline and glutamine. The amino acids are represented by the letters on either side of the glutamine, which is represented by the black letter Q. The intestinal TTG modifies the gluten peptides by changing glutamine to glutamate. The symbol for glutamate is the letter E. In celiac disease, T cells recognize the gluten peptides and become activated. They release cytokines that damage the surrounding intestinal tissue and inflame the epithelial cells. This is the disease-determining event for celiac. Activation of gluten-reactive T cells simultaneously supports the maturation of B cells. When gluten appears, B cells express antibodies on their surface that capture deamidated gluten peptides. Some activated B cells mature to become dedicated plasma cells that secrete specific antibodies for deamidated gluten peptides that are found in serum and that are used for celiac diagnosis. Through the action of TTG, gluten peptides can also bind onto proteins, including TTG itself. Complexes of gluten peptides and TTG can attach to antibodies on the surface of B cells. These also mature into dedicated plasma cells and produce TTG antibodies that support celiac disease diagnosis.